Okay, guys. Example 3 says on June 14th, 2002, the distance between Earth and the Moon was about 375,000 kilometers. Okay, that's pretty cool. You realize that the Earth and the Moon are not always the same distance apart. Okay, the orbit of the Moon around the Earth is not a circle. It's an ellipse. Okay, sometimes the Moon's closer, sometimes it's farther away. There are times when the Moon's about 225,000 miles from the Earth. There are times when it's closer to 260,000 miles from the Earth. So, just to give you an idea, whenever men went to the Moon, right? First thing, they didn't have to shoot. You don't look at the Moon and go, oh, and take off and go straight to the Moon. You have to determine where's the Moon going to be when we get there, right? Because you don't just show up on the Moon. It takes maybe 3 or 4 days to get there. All right, well, where's the Moon going to be in 3 or 4 days? Well, it's going to be over here. Okay, but remember, it's not a circle. I didn't draw a circle perfectly, but it's more of an ellipse, like this. Sometimes it's closer to the Earth, like here, and sometimes it's farther away from the Earth. Okay, there's a part of advanced algebra called conic sections. Conic sections are shapes that we can get out of a cone. If you look at a cone, right, at the bottom of the cone you have a circle. Okay, if you cut off a slice of the cone like that, the shape it makes is a parabola. Alright? If you cut a cone this way, but it's not horizontal to the ground, it makes a shape that's called an ellipse, like that. That's why they call them conic sections. It's these different shapes that you can get from a cone. An ellipse is one of the conic sections, and we can use formulas to determine different points on an ellipse, right? So when you watch Apollo 13 and you wonder whether or not Tom Hanks is going to get back alive, right? And they're trying to point toward the Earth and all that good stuff, and all those mathematicians have their slide rules out and they're trying to make sure all the numbers are right. You know the scene I'm talking about? Yeah. Okay. All right. They really did. I mean, they needed mathematicians to do that. They wouldn't use slide rules today because we have electronic calculators. Okay, we'd be able to figure out those numbers, and we have computers that could do that, but their computer was shut down. That's why they had to be able to do it by hand. Okay? So anyway, none of that has to do with this. It says, on that day, a traveling asteroid missed Earth by about 32% of that distance. Okay. How far away from Earth was the asteroid at that time? So, Julian, can you give me the question that I need to answer here? Can we write a question? Oh, let me get a pen. Here we go. What is 32%? Beautiful. Now let me ask you this, Julian. Would you be able to put this into the percent proportion? You know, is over of equals percent over 100. Would you be able to do that? Okay. Right. We can do that. We know how to do that. We're going to change this just straight into an equation. All right? So, let's see. What means x? Leo, what's his mean? Good. Equals. Nick, how do I put this in the equation? 0.32. Perfect, Nick. Exactly right. I got to change it to a decimal so I can use it. Spencer, what's of mean? Multiply, so I'm going to put my parentheses. What goes in the parentheses, Dane? Excellent. All right, so x equals 0.32 times 375,000. What is that number? Taggart. 1,200? 12,000. So 12,000 miles. So the asteroid was about 12,000 miles from the Earth. All right? That's about, is that about right? Scratch that out. Okay, what is 32%? It's got to be bigger than 120, guys. 32%'s got to be like 120,000. 120,000, I'm sorry. Okay. I'm sorry, I thought you just said 120. Okay, 120,000. All right. Excellent. Good job, guys. Let's look at the last one.